We want to find the perimeter of this polygon, this triangle, and we know that the perimeter is the length around. So why don't we write this as P for perimeter is 7 millimeters plus 4 millimeters plus 5 millimeters. And the order here of these sides doesn't matter. So what we're going to get here is, what do we have? 7 and 4 is 11. 5 more is 16. So we're going to say that the perimeter here is 16 millimeters. In number 3, we want to find the perimeter of an equilateral triangle. Now, equilateral means equal sides, right? Equa and lateral for sides. So here's a triangle. We're given one side is 8 yards, but it's equilateral, so all the sides are 8 yards in length. So the perimeter is going to be 8 yards plus 8 yards plus, let's try that again, plus 8 yards. So the perimeter here is 24 yards. And in number 4, we're asked to find the perimeter of an isosceles triangle. Now, an isosceles triangle is a triangle that has two sides of equal length, like maybe we draw that, and then a third side of a different length. So we're given that these lengths here, these sides are 14.5 inches, 14.5 inches, and that the third side has a length of 25 inches. Now the perimeter is going to be 14.5 inches plus 14.5 inches plus 25.5 inches. When I add those together, I got the perimeter being 54 inches. Number 5, we want to find the perimeter of a square, and one side of the square is 0.013 millimeters, tenths, hundred thousandths, 13 thousandths millimeters. So it's a square, so we're going to add this number to this number, to this number, to this number, or just 4 times that number. So we can say that the perimeter is 4 times 0.013 millimeters, and making that multiplication, I got 0.052. 0.052 millimeters for the perimeter of this square. Number 6, we're going to find the perimeter of this rhombus. Now a rhombus is a parallelogram having all equal sides. Or just imagine a square, just kind of pushed over to the right in this case. So it's just going to be the same. To get the perimeter, we're going to use the same idea as we did for the square. We're just going to add up all 4 sides or multiply by 4. So we're going to have the perimeter here is 4 times 18 meters. So the perimeter is going to be 72 meters. Now in this problem here, this is a parallelogram, and what we're given is that one side measures, let's write it here, 15.5 centimeters, and the adjacent side, now adjacent means right alongside of it, is 13.5 centimeters. Now, this is a parallelogram, so opposite sides have the same length. So we could just add maybe this number plus this number, plus the 13.5 again, plus the 15.5 again, or we might think of doing it this way, where the perimeter is 2 of these 13.5s, right? We've got this one and this one, so we have 2 of times 2 of those, plus 2 of those 15.5s. I left the centimeters off. So this is going to give us that the perimeter is 27 centimeters plus 31 centimeters, and when we add those together, we're going to get a perimeter of 58 centimeters. Let's find the perimeter of this rectangle here. So we've got this piece here, this side being 78 feet, and this side here being 42 feet, and we're going to have 2 of the 78s, 2 of the 42s. So we can write the perimeter as 2 of times 2 of those 78 feet plus 2 of those 42 feet So this will give us 2 times 78 is 160 feet, plus 2 times 42 is an 84 feet. And then when we add those together, I get 240 feet for the perimeter of that rectangle. Now, number 9, we've got a circle, and what we want to do is find the circumference of this circle. So we have a formula for circumference, which is really the perimeter, just a length around. In fact, we have two formulas. We have this one, circumference is 2 times pi times the radius, or we have this one, the circumference is pi times the diameter. Now really, if you look at this, see this 2r here? That's twice the radius, that's the diameter. So just look at the picture that you have and pick out which formula you're going to use depending on which information you have. We happen to have the radius, so I think what we're going to use here is we're going to use this formula right here. So we're going to get that the circumference is 2 times pi. Now we're going to approximate pi with 3.14 times the radius, which is 14 inches. And then when I make that multiplication, I came out with 87.9 rounded off. I actually got this. I got 87.92 inches, but I'm going to round this off to 87.9 because we're asking this problem to round it off inches to the nearest tenth. Now in problem 10, we still want to find the circumference, but let's use this formula here now. Let's use pi d because we're given the diameter here. In the last problem, right up here, we were given the radius, so we used 2 pi r. This problem we're given the diameter, so we'll use pi d. So we will get circumference equals to pi. Again, we're going to approximate it with 3.14 times that 48 centimeters. Now when I multiplied this on my calculator, I got 150.72 centimeters, but the problem is asking us to round to the nearest tenth. So let's write this as 150.7 centimeters for that circumference. And in number 11, we've got a polygon, this 5-sided figure here, and we want to find the perimeter. Now, the picture is not to scale here. Notice that this side is 81.9 inches, and so is this one. This side looks longer in the picture than does this side, but it is just a picture. So we're going to go with these measurements. To get the perimeter, we know we're just going to add them all together. 318.1 inches. Now, in 12, what we want to do is find the perimeter of this. The book's calling it a composite geometric figure. So to get the perimeter, we know what we're going to do. We're just going to add up all of these numbers here, so we need to start someplace. How about if we start at the 9 and then just go clockwise? So going clockwise, I got 9 plus 2 plus 4 plus 9 plus 5 plus 11. And adding those together, I came up with 40 meters. We've got this field here that measures 441 meters in length and 24 meters across like this, and we want to fence it. And the fencing costs, okay, what is this? The fencing is going to cost $2.19 per meter. So each meter of fence costs $2.19. So first of all, let's find the perimeter. What we want to do is find the total cost. So find the perimeter first. So what we're going to get 2 of those 441 meters plus 2 of those 24 meters. So this is going to give us 882 meters plus 48 meters. When I add those together, I got 930 meters. And now to get the cost, we're going to have 219 times 930. So when I multiplied here, what am I getting? I got 2036.70 dollars. Let's just look at this more closely. Here's what we're getting for the cost. Here's how we could actually do this. We're getting 2.19 dollars per meter times 930 meters. Then the meters cancel, and we end up with $2.19 times 930. Now this computation here looks like this computation here, but this one has the units applied to it, this one doesn't. So this is technically how we get to our final result, which is this one right here. In 14, we're told we've got a meteor crater. Let's draw something. Here's land, and then here's this meteor crater, and then more land. And we're given the diameter from here to here, one side to the other, that's 4,200 feet. And what we want to do here is find the distance around the crater. Well, okay, that must be like this, or if you come out three-dimensional, it would be, imagine this circle just coming out here like this. So what we're actually trying to do is finding the circumference of this circle. So we're given the diameter, so I'm going to use pi d, 3.14 for pi, and then 4,200 feet for the diameter. And when I multiplied that, I got the circumference, the distance around that crater, to be 13188 feet. I'll put a comma there, so 13,188 feet around that crater. This problem we're going to work a little bit differently. Here's what we're given. We're given that the circumference, the length around this coin, is 7.51 centimeters, and what we want to do is we want to find the diameter. Well, we just happen to have a formula that has C and D in it, and that formula is that their circumference is equal to pi d. Let's put in these numbers that we know. So C is 7.51 centimeters equals, we'll approximate pi with 3.14 times d. And now we're going to solve this equation. We're going to divide by that 3.14. So we're going to divide by 3.14. So we're looking at this. 7.51 centimeters divided by 3.14, that's equal to d. Now, when I just did this on my calculator, here's what I got. I got 2.391719, dot, dot, dot. It just kept going. But we're, of course, not going to use all these numbers here. We're just asked to round to the nearest tenth. So let's write this then as the diameter here, now to the nearest tenth, right, there's the tenth. Look to one digit to the right, it's a 9, so we're going to round this up. So how about 2.4? So we're going to have 2.4, and we still have centimeters. Here we've got a flower bed that's made up of a square with semicircles around the square. Now, for the one I'm doing here, one side of the square is 24 feet. So we want the perimeter of this flower bed. If we start up here, what we're looking for is this length here, that length, and that length all added together. This is a semicircle, so this is half the circumference of a circle. Now, because we're given a diameter here, right, this is a diameter, we're going to be using this formula. I'm going to use this. Circumference is equal to pi d. And technically, we have half of this, right? Because here's half of the circumference. So we're going to have a half here, a half here, a half here, and a half here. So I'm going to write this as, say, 1/2 pi d for the top, plus 1/2 pi d for that right semicircle, plus 1/2 pi d for the bottom semicircle, plus 1/2 pi d for the leftmost semicircle. Now, these are really all like terms, aren't they? Pi d, pi d, pi d, pi d. They're all the same type of term. All I have to do is add these coefficients. So 1/2 and 1/2 is 1. Here's 1.5. Here's 2. So I have 2 pi d. Now the 2 pi d, that's going to be the perimeter. And I think that's going to make sense here, because if we come back up here to this idea, the circumference of a circle is pi d, so I have this semicircle and that semicircle actually give me a full circle. This semicircle and that semicircle give me a full circle, so I've got 2 full circles. So this perimeter is going to be 2 times pi, 3.14 is our approximation, times the diameter, 24 feet. And when I multiply that out, I got 150.72 feet. But the book says just round it to the nearest integer. So rounding to the nearest integer, that's the nearest integer right there. This number to the immediate right is above 5, so I'm going to round this to 151. So the perimeter of this flower bed is 151 feet.